Hello everybody, hopefully you are doing well. We'll continue with our second part of chapter 12, lesson 1, heat. We'll continue this lesson today. Hopefully you have your books with you alongside pen or pencil to take notes. So as you know that we studied about conduction, convection, radiation. We'll continue with infrared rays. Hot objects radiate heat. The electromagnetic rays they produce are called the infrared rays. Now they are called infrared because they are close in color to red visible light. Now one thing is there that we cannot see the infrared rays, but you can feel the infrared rays. For example, when you stand in the sun, you can feel that heat and that rays. Or let us say when cooks use infrared rays when they broil food in an oven, the red hot coil gives off infrared radiation to cook food quickly. So infrared rays heat the surface of an object more than its center. Some snakes, for example, and other animals have special sensory organs to detect infrared rays. Scientists also have built special instruments and cameras so humans can do the same. Computers can artificially color the images that the cameras take. You can use the infrared cameras to take pictures of objects even in the middle of the night. Now we come to heat capacity. Now not all materials change temperature at the same rate. For example, a gram of cooking oil warms more than a gram of water with the same amount of heat. The gram of cooking oil warms more faster than the gram of water with the same amount of heat. We say that oil has a lower capacity for heat than water. Now materials with low heat capacity changes temperature quickly. A material's heat capacity depends on how actually the particles hold together. For example, water molecules are attracted to one another. This is why water has high heat capacity, because the molecules are packed in such a way. Every substance has its own unique heat capacity. Now, you know that conduction, convection, and radiation, when heat travels, now it does not always travel at the same speed. Radiation, for example, will carry thermal energy at the speed of light, which is the fastest thing to travel in the universe. Convection, on the other hand, are the currents through which heat passes in liquids or gases. They're really faster than 56 meters per second. Conduction typically carries thermal energy much slower than either of the other two methods. Now you might be saying why. And conduction energy is transferred as particles bump into each other, they jump into each other. Thermal energy can only move from one side of an object to another side by moving through all the particles in between. So this exchange of thermal energy actually takes time. So this is what actually thermal conductivity is. It's the ability of a material to transfer heat. If a material conducts heat easily, it is called a good thermal conductor. But if a material does not conduct heat easily, or you could say it conducts heat poorly, it is a good thermal insulator. Now most metals are thermal conductors and non-metals are thermal insulators. Thermal conductivity usually increases with density. When you talk about the particles, the closer the particles are together, the quicker heat can move through them. If you see the solid particles, right, they are more closer to each other, so the more quickly the heat is going to move through them. This makes solids better conductors than liquids, because in the liquids you see there's some gap between the particles. But on the other hand, gases, there's a lot of gaps, so this makes the gas a very poor conductor of heat. So it all depends on those particles. Packed particles are going to make things, anything which is made up of packed particles solid is going to be a good conductor of heat. Liquids are not that good conductors, but they are somehow they allow the heat to move through it. But gas, they are the poor conductors of heat if we compare the three states of matter. That was the lesson for today. Hopefully hopefully you understand. If there is any question, please feel free to ask, and we'll continue our lesson in the next period. Thank you for watching.